Welcome students to your channel Pradip Sir Classes has PSC, and today we are going to discuss about numericals related with unit and dimension, and this is the numerical king series, that is AC Verma solutions. Okay, and it is volume 1 and chapter 1 from question number 14 and 15. So question number 14 and 15 are almost related with derivations, that is dimension of homogeneity, that is we can all the applications of dimensions, that is how we can derive a particular equation with the help of dimensional analysis. So let's say student, for doing the numericals, and before, if you are first in that particular class, then go back to the previous one and enjoy all the numericals, that is from 1 to 13, and come back again. Okay, so let's first of all students write down the questions. Okay, so the question is, the kinetic energy of a rotating body depends on its moment of inertia. So kinetic energy, and this is K. And first of all students, it will be better that first of all you have to know all the dimensions related with physical quantity. So check the dimension. There is kinetic energy, that is ml square t minus 2, and it is equal to the dimension of work done. And then on a moment of inertia, MOI, that is moment. If you are not familiar with that particular physical quantity, so that it is given the moment of inertia of a sphere about its diameter is 2 by 5. So 2 by 5 mr square, it is the equation mr square, and so the dimension of moment of inertia will be m into r mean length, so ml square. And the kinetic energy of a rotating body depends on its moment of inertia and its angular speed. So angular speed, and this is symbolically represented as omega, and this is equal to theta by t. And so theta is a proportion, it is a ratio, theta equal to arc by radius. So L by L cancel this one. So what is the dimension of t? That is t. So t minus 1, and this is the dimension of omega. So all the physical quantity related with kinetic energy, that is ml square t minus 2, and the moment of inertia, that is ml square, and the angular speed, that is t minus 1, and you have to relate relations k equal to kappa. It is a proportionality constant, Greek alphabet, and I to the power of a and omega to the power of b. So k equal to kappa, kappa, I to the power of a and omega to the power of b, and I have to calculate the value of, determine the value of a and b. So first of all students, place the dimension of the physical quantity, related physical quantity. So ml square t minus 2, and this is kappa is the proportionality constant, and it is a dimensionless constant, so its dimension is 1, or you can write as kappa. And I that is moment of inertia, and it is ml square, and omega, so this to the power of a, and omega, that is t minus 1, so t minus 1, this is t minus 1, so t minus 1 whole to the power of b. Okay, then you have to compare on both sides, that is LHS and RHS. So in LHS, here m equal to, so ml square and t minus 2, and this is equal to kappa and m to the power of a. Here it is m and L to the power of 2a and t to the power of minus b. So if we compare m with this one, then we get a equal to 1, a equal to 1 and 2a. 2a equal to 2 and minus of b, and this is equal to minus 2, or a equal to 1. You can calculate here also, and then b equal to 2. So this is the answer, a equal to 1 and b equal to 2. So this is the for that particular rules, or you can use the dimension of homogeneity. Dimension of homogeneity tells about the dimension of this is equal to this one, and then compare, and you easily calculate the value of this and this one, or you can derive a particular equation with the help of dimensional analysis. So question 15 is cleared. I think 14 is clear, and then write down question number 15. Okay, so question number 15, and this is, first of all, students, always I say pause the video and write down the question and realize that particular one, and then see the particular solution. So theory of relativity reveals that mass can be converted into energy. Yes, and it is most of all you know that from 7th or 8th standard, that is E equal to mc square. This is the equation is given, and you have to derive that particular equation. So the energy so obtained is proportional to certain powers of, so energy is proportional to certain powers of m and certain power of the speed c, and you have to derive that particular relation. So we don't know at that particular moment that E equal to mc square, we have to derive, so we can write as E is proportional to m to the power of x, and E is proportional to c to the power of y. So E is proportional to m to the power of x and c to the power of y, or we can take a equation proportionality constant, that is k m to the power of x and c to the power of y. So the dimension of energy, that is ml square t minus 2, and a proportionality constant, then mass to the power of x, and c means velocity, that is L t minus 1 to the power of y. So k m to the power of x, L to the power of y, and t to the power of minus y, and here m L square t minus 2. So m, if we compare this one, then you can get x equal to 1. So x equal to 1, comparing both sides, and then y equal to 2, then y equal to 2. So x equal to 1 and y equal to 2. Now you can easily derive the particular relations, and you have to put that particular value in this equation. So E equal to kappa and m to the power of 1, so it is m, and c to the power of 1, that is c square. And this is the inability or demerits of dimensional analysis, that it cannot specify or cannot calculate that particular value. So if you take that particular one as 1, then E equal to mc square. Okay, so this is the relation, and you have to take here at 1, and if you don't know that what is the value of 1 or 2, you have to take, then just you have to write that particular equation, and you will get full marks. Okay, so it's not I think that it is all the numericals, that is 14 and 15, you have cleared that particular ones, and wait for the next class or for the next numericals, and I come back something, it may be for tomorrow. Okay, and last of all, if you like my channel, then please subscribe, and as I say, last of one, continue your study, and thank you.